Okay. So in section 5.1, we are going to work with proportions. This is what a proportion looks like. And when you have a valid proportion, you can always cross multiply and set the cross products equivalent to each other. All right. In this section, we're going to verify proportions, and then we're also going to solve proportions. All right, so let's go to our textbook and start to learn how to verify whether an expression qualifies as being a proportion. So in section 5. We already did 5, 1, 2, and 3. I'm sorry, ladies and gentlemen, this is section 5.4. My bad. This is section 5.4, proportions. We're doing 5, 4, 5, 5, and 5, 6 today. All right, so section 5.4. All right, so let's go to section 5.4 in our textbook. It is entitled Proportions, and we're going to jump all the way down to the homework set and get started here. Okay. All right. Let's see here. I can blow this up here a little bit. Okay. All right, so ladies and gentlemen, this is section 5.4 in our textbook, and this is page 243. On page 243 in your textbook is where the problems begin, of which I will assign some of these for your next homework assignment. For like number 1, they give us a proportion here. 1/3 is equal to 5/15, and we're assuming it's a valid proportion. What would be the means of this proportion? What numbers would be the means? Anybody?
Wouldn't it be 5?
Well, the means would be both 1 and 15. Those are
1 and 15. Okay.
1 and 15. Okay. Those are the means, 1 and 15.
1 and 15.
All right. Now, what do you think the extremes would be then?
It would be 3 and 5.
3 and 5. Okay. All right. Now, ladies and gentlemen, do you think that this is a valid proportion here? In other words, if I take the product of the means, if I take 1 times 15, is that equal to the product of the extremes, 3 times 5? Does 1 times 15 equal 3 times 5?
Yes.
It does, doesn't it? So that would be a valid proportion. That makes sense? That's a valid proportion. Because the product of the means is equal to the product of the extremes. All right. All right, let's jump on down to one. Let's see, we have some fractions. Look at number 5 here. That is a proportion. And what would be the means of this proportion? The means. Well, the means would be the numerator of the left side and the denominator of the right side. So the means would be 1/3 and what, 6? 1/3 and 6 would be the means. What would be the extremes then? Well, that would be 1/2 and what, 4? 1/2 and 4 are the extremes. And do you think that's a valid proportion? Do you think 1/3 multiplied by 6 is equal to 1/2 multiplied by 4?
No.
Well, bring up the calculator and find out. Let's dial up the machine here quickly. Okay, so I'm going to bring up the TI-30XS here. And let me bring this document up again. Now bring the calculator. Oh, I can't do that. All right, so we're trying to see, what are we trying to see? We're trying to see if 1/3 times 6 is equal to 1/2 times 4. Let's do 1/3 times 6 first on our calculator. To do that, we hit our fraction button. All right, and we type in 1/3. Then we multiply that by 6. And what's 1/3 times 6 give us? gives us 2, doesn't it?
Yeah.
Now we're going to see if that's equal to 1/2 times 4.
Yes.
And I think we'll discover that it is. Do you agree? So that is a valid proportion, since the product of the means 1/3 and 6 is equal to the product of the extremes 1/2 and 4. So yeah, as it turns out, ladies and gentlemen, looks like number 5 would be a valid proportion. So do we understand what the means and the extremes are of a proportion? Are we good? Okay. Let's move on to deal with other issues here. All right, now these problems here, they're going to give us several valid proportions, and the instructions say find the missing term in each of the following proportions. In other words, wherever we see a variable or a letter, that means that that quantity is missing, and we need to find what numeric value it would be for the statement to be a valid proportion. All right, it says for problems 30 through 36, write your answers in decimal form. For the other problems, write your answers as fractions reduced to lowest terms. Okay, so let's try problem number 9 here first. So this is problem number 9, and this is on page 244. Okay. We have a proportion here that says 3 is to 5 as 6 is to x. And that's going to be our job to take this proportion and do what? Solve it for the missing quantity, which means to solve it for x. So we're going to solve this. We're going to solve this proportion for the missing quantity x. Okay. So the way I read this proportion again, as I said, 3 is to 5 as 6 is to x. Everybody understand how I read that? 3 is to 5 as 6 is to x. Now, ladies and gentlemen, in order to solve this proportion for x, the missing quantity, we can do what? Well, what we can do is we can cross multiply and equate the cross products. Do you agree? We can set the product of the means equal to the product of the extremes. So that means that I can take 3 times x, that's the product of the means, and then I can set that equal to 5 times 6. Everybody see that there? So I cross multiplied 3 times x, and I'm setting that equal to 5 times 6 here. Now 3 times x is 3x. And that's equal to 5 times 6. What's 5 times 6?
30.
30. Do you remember the last section we left off with 2 days ago, section 5.3, ladies and gentlemen? Do you remember how we solved equations like this by dividing?
Mhm.
What would I divide both sides of this equation by to solve for x, to get x by itself?
3.
3. So we divide the left side by 3, and I'm going to divide the right side of my equation by 3. And, you know, by doing this, I think we're going to get our what? We're going to get our solution to this missing quantity in this proportion. So therefore, 3x divided by 3, the 3 is reduced down to 1. So we're left with 1x or x, and that's equal to, what's 30 divided by 3? 10. Ladies and gentlemen, we're done. We have found the missing quantity in this proportion. X has got to be equal to 10 if this is to be a valid proportion. Did that make sense how we solved that there? Okay. Any questions how we solve that proportion for the missing quantity X? Again, we equated the cross products. We set equal the products of the means and the product of the extremes. And then we solve for X. All right. Now that was a nice one because we had nice whole numbers. Do you think we're always going to have nice whole numbers or nice numbers like this? Probably not, correct? All right. All right, let's see if we can solve another one here. Let's go to problem like number 12. And they want us to solve this proportion for the missing quantity. So, you know, I could even shorten the instructions up to just saying what word could I use in place of all those words they got up there? I could use one word. to summarize all these instructions up here? What word would that be? Anybody want to take a guess? The word what? What are we trying to do with this? We are trying to,
And why?
yeah, we're trying to find why. So what word would embody that requirement? We're trying to, the word I'm searching for starts with the letter S.
So,
Solve. We're trying to solve this proportion. Do you agree? So ladies and gentlemen, I could summarize all those instructions, all those words with one word, solve. And by seeing this word solve, we should know what it means to do. It means that we're going to have to find this missing quantity in our proportion. We need to find the value of that for the value of y here. Okay, we got to find y. Now to do that, what am I going to do? I'm going to multiply my means together, 2 times 10. And then I'm going to set that product equal to the product of my extremes, y times 6. So essentially, I'm going to equate the cross products, y times 6. But you know, y times 6, we don't call it y6. We call it more appropriately what? Instead of y6, we say
6y.
6y. Everybody see that there? All right, so that's the equation now we're having to solve in order to solve this proportion for y. What's 2 times 10?
20.
That's equal to 6y. Now, how would we solve this equation for y? We've solved many of these back in section 5.3 the other day. We would divide both sides by what?
6.
By 6. Divide the left and the right side of this equation by 6. Unfortunately, 6 does not divide evenly into 20. And so the best we can do is at least reduce 20 over 6 down. And the right side reduces down to just 1y as the 6 reduces down. 6 divided by 6 reduces down to 1. And 1 times y is better known as just what y. Now this 20 over 6, can we reduce it? Can 20 over 6 be reduced? Can you think of a number that divides into both 20 and 6?
3.
3, well, 3 divides into 6, but 3 does not divide into 20.
2.
2 will work. Let's divide the numerator and denominator down by 2. 20 divided by 2 takes this numerator down to 10, and 6 divided by 2 is 3. And I think that's it. I don't think we can reduce 10 over 3 anymore. So there we go. So your answer is y must be equal to 10/3. And we have solved that proportion. We have solved that proportion. Is this making sense how we're solving proportions so far?
Mhm.
Okay, now so far we've had kind of nice, numbers, nice whole numbers to work with in our proportions, but we're not always going to unfortunately have that luxury. Sometimes our numbers might start to become fractions or decimals or mixed numbers. Do you agree? It might be become more adventurous, to say the least. All right, let's try to seek one of those out there. That might be a little bit more complicated. Look at this one here, number 21 here, Liz. We're trying to solve this proportion for what variable, what letter, what missing quantity?
It'll be y still.
Y. Yeah, we're trying to solve for y, correct? All right, but notice the numbers now, some of these numbers are fractions, and so we might have to be a little bit more cautious in solving this one. So I'm going to try to solve this proportion here, which is saying 1/2 is to y as 1/3 is to 12. And we're going to try to solve this proportion by, solve it for y. Okay. So how would I solve this proportion for y here? Well, I'm just like we did with all the other ones. I can cross multiply and equate the cross product. So I can take 1/2 and multiply it by 12. 1/2 multiplied by 12, or 12 over 1. And then I can set that equal to y times 1/3. y times 1/3 is more appropriately called 1/3 what? Y?
Mhm.
Okay. Now, so what would we do with the left, the left side? Well, we got to take 1/2 times 12. You can do that either manually or you can use your calculator. And if you wanted to use your calculator, you would take 1/2 times 12. So you dial up your fraction template, type in 1/2 times 12. And 1/2 multiplied by 12 gives us what? Gives us 6. Everybody see that there? 1/2 times 12 is 6. All right. If you wanted to work it out manually, you would say 1 times 12 is 12 and 2 times 1 is 2. But what does 12 over 2 reduce down to? Reduces down to 6 anyways, doesn't it? So 6 is equal to 1/3 times y. Okay, now ladies and gentlemen, how do we solve this equation for y? How do we get rid of the 1/3?
You divide the 1/3.
We divide both sides of our equation by 1/3. So we're gonna have to divide the left side of our equation by 1/3. And we divide the right side of our equation by also 1/3. Now, on the right side, the 1/3 divided by itself reduces down to 1, and 1 times y is just better known as what? Y. But on the left side, ladies and gentlemen, we're having to divide 6 by 1/3. In other words, the way this is written is it's saying 6 divided by 1/3. Let's write it literally that way. 6 divided by 1/3. Now you can either do this manually or you can just jump on your calculator and figure that out. So let's go to our calculator, ladies. I'm going to dial up 6 divided by 1/3 to see if we can do that in our calculator. So we have 6 divided by 1/3. So go get your fraction template and type in 1/3. Hit enter and you'll get your answer. And it should be 18. Everybody see that there? 6 divided by 1/3 is 18. Okay. That's the calculator way of determining what 6 divided by 1/3 is. I can show you manually how we would get the same result of 18. Ladies and gentlemen, when we perform division of fractions, we change division to multiplication and we flip the second fraction upside down always. So we have to reciprocate 1/3 and call it 3/1. Now what's 6 times 3?
18.
We got our same answer of 18. Do you agree? So whether you want to do that step on your calculator, 6 divided by 1/3, or work it out manually, you should get 18. Make sense? Okay. Solving proportions for the missing quantity. And the missing quantity is denoted by a variable wherever it appears. Wherever it appears in the proportion, we have to solve for the variable. Okay. Any questions on this page here? What just happened in solving those two proportions there? Okay. Let's go back to our book here. Let's see. Okay. Now let's see if we can solve one that has like maybe some decimals in it. But before I do that, I noticed like 29 or 30 kind of give you a different look, don't they? Maybe so much so that we would be confounded in understanding what to do with them. Let's do number 30 here. Let's try to solve that proportion for y. Okay, so we're going to try to solve number 30 for y because that's the missing quantity in the proportion. Now, this really don't look like a proportion, does it? Kind of looks strange. We never really seen this before. But hey, do you agree that I could put 0.75 really over what number and no harm would be done?
1.
You can always put anything over 1 and it's still the same thing, correct? Anything divided by 1 is still itself. So let's do that. Now it looks like a proportion. Now, how do we solve for y? Well, we cross multiply. We multiply the means together. Y times 1. What is y times 1?
Just Y.
just y, and we set that equal to the product of the extremes, 16 multiplied by 0.75. You can multiply this out manually if you want, or you can just, use your calculator. So let's go to the calculator and multiply 16 times 0.75. So bring up the calculator. We'll multiply 16 by 0.75. So 16 times 0.75. Hit enter, and what do we get?
12.
12. We get 12. Okay, 16 multiplied by 0.75 or 75 hundredths, correct? 16 times 75 hundredths is 12. And so y must be equal to what? 12. Does anybody want to see me multiply this out manually? Just curious, anybody? I'll take that as a no. All right, so there's our solution, 12. Do you agree? Y is equal to 12. All right, are we seeing how we're solving proportions for the missing quantity, ladies? Just making any sense here so far?
Mm-hmm.
All right, let's go back and see what else we have going on here. So it doesn't matter how big the numbers get either, because what? We don't care. We have access to a calculator, don't we? So we don't care how big the numbers get. All right, so I'll tell you what, ladies, I'm gonna cook up some problems that I want you to do for classwork number 1. And today is what, January 20th, correct? We'll call it classwork 1, January 20th. I want you to try to solve these proportions here. Okay. So I'm gonna dig up some good ones here. See if you can solve this one. Hold on, I'll show you the classwork in a moment. I'm just writing down a couple problems here, and then I'll let you look at it. So we're solving all of these that I want you to solve. So just make sure to take note of that. And let's see if we can do this one here. Let's see. Okay. And then I'm going to give you one more here. I'm going to give you one where we have some big old numbers here. All right. But it don't matter. Nothing changes. We still work the same way. It doesn't matter how big or small the numbers are. And we have a calculator to take the sting out of the elementary operations. Agree? All right, ladies and gentlemen. So we'll call this class work number 1. It's January 20th. See if you can do those problems, and we'll check the results. Okay. All right, anybody get number one? What is n equal to?
6.
6? Okay. Did we all get 6 for number one?
Yes.
All right, anybody need to see that one done? Number one, answer should be 6. Okay. Now, number 2 there, did anybody get an answer?
3/10.
For number 2?
Be 1 over
Yeah.
10. I think.
Right. A
I
little
got
bit of-
1 over.
What'd you get?
I got 1 over 10.
Okay, 1/10, 1/10, 1 over 10. Anybody get anything different? Somebody got 3 over 10?
Yeah,
I got 0.1.
0.1. All right, so we have quite a smorgasbord of responses here. Because of that, let's work this out. We would take 0.3 and multiply it by 0.8, 3/10 times 8/10. And then we'll set that product equal to this cross product, x times 2 and 4/10. So 2 and 4/10 x. Now, 3/10 multiplied by 8/10 is going to give you, should give you 24 hundredths, which is 0.24, 24 hundredths. Then we're going to have to divide both sides of this equation by what? 2 and 4/10 to solve for x. All right. And notice these 2.4 is reduced down to 1 on the right side, leaving you 1x or x. And what's 0.24 divided by 2.4 here? Or what's 24 hundredths divided by 2 and 4/10? Anybody get that there? And I believe it would be what, 1/10. Do you agree? Now you could cite the answer as what, 0.1, or you could, cite the answer as 1 over what, 1/10, 1/10. Does that make sense how we got that?
Yeah, I redid it. I got 1/10 too.
Okay, alrighty. Anybody get number 3? Feel good about that one?
Be 107.
107?
Yes.
Okay. Anybody else get 107?
Yes.
Yes.
All right. So that seems to be the consensus. So 107. Now, the way we got that, we would take 321 and multiply it by what? 376. And, as you guess, that's going to give you kind of a sizable number. And if you take 321 and multiply it by 376, you're going to get a big number, 120,696. And then we'll divide that by what? 1,128.
Mhm.
And we do get 107. You are correct. Nice job. All right, ladies and gentlemen, makes sense. Classwork number 1. Okay, just push that aside because there will be other classworks here and you can get all this to me by midnight tonight, hopefully. All right. Okay, classwork number 1. Okay, now we're going to turn our attention to the next section, section 5.5. All right. Okay, so we're going to start applying proportions to word problems, ladies and gentlemen, or application problems. And we probably do proportional reasoning every day, not realizing that we're doing such a thing. For instance, here's an example of proportional reasoning. Let's say that to serve 2 people, we have to use, let's say, 3 cups of milk in a recipe. But if we double the number of people we're going to serve from 2 to 4 people, we're going to have to double the number of what cups of milk for the recipe. Does that make sense? That's proportional reasoning, ladies and gentlemen. All right. We do it all the time, but we're going to do it formally now in section 5.5. So the best way to learn how to apply proportions to application problems is by actually doing application problems. Let's go in our textbook to section 5.5. And it's entitled Applications of Proportions. Okay, so we're going to actually put proportions to work for us so that they can take care of business for us out in the real world. Let's go right on down to the problems here. These begin on page 249 in your textbook, the problems. So we'll dive on down to page 249. And let's begin. I'll work out several of these here. I'm going to try number 2 here. It says an airplane, and the instructions say solve each of the following word problems by translating a statement into a proportion. Be sure to show the proportion used in each case. Okay, so we're going to see if we can do some of these application problems here. All righty. Okay, so what we're going to do, ladies and gentlemen, is we're going to read this problem. We're going to set up a proportion. So let's read. It says an airplane flies 1,260 miles in 3 hours. How far will it fly in 5 hours? Now look at the key assumption in this problem is assuming that the speed with which the airplane is flying during 3 hours remains the same during the next 5 hours. Do you agree? That's the key. Because if this airplane speeds up or slows down between the 3 hours and the 5 hours, then obviously it's not going to cover what, proportionally speaking, the same amount of distance. Does that make sense, sir? So that's the key assumption, that this airplane continues to fly at the same speed for all times. Okay. So an airplane flies 1,260 miles in 3 hours. How far will it fly in 5 hours? We don't know how far it's going to fly in 5 hours. We'll give that a variable name. Call it X maybe. Okay, we're going to set up a proportion to answer this question. So, ladies and gentlemen, I'm going to set up one rate on the left side of my proportion. It's going to be 1,260 miles is to how many hours? 3 hours. As how far would the airplane fly in 5 hours? Let me show the proportion that I set up. There you go. Everybody see this proportion I set up here? We know an airplane can fly 1,260 miles per 3 hours. They want to know, okay, how far can it fly in 5 hours? Now, when you're setting up a proportion, it's critical, very important, that your units must be the same across. So this is very important, so important, in fact. I'm going to write this down. Units must be the same across numerators and denominators. Now, what is that saying? Well, it's saying that if I have miles in the numerator here, this better be what in the numerator over here. This better also be what? Miles. Agree?
Right.
Miles here, this better be miles. If this is hours, this better be what?
Hours.
Hours. Okay. So, ladies and gentlemen, this is one valid way of setting this proportion up to answer this word problem. You know what? But we could have set it up this way. Here's an equivalent proportion that would give us the same answer. I could have said, instead of on the left side, my rate being this, I could have said my rate is 3 hours per 1,260 miles. But if I set my rate up that way on the left side of this proportions equation, the right side rate would have to have the same units across the numerator and denominator. So now I would have to have what? The 5 hours in the numerator over here and X in the denominator. Does that make sense there? So it doesn't matter whether you set up this proportion or this proportion, you're going to get the same answer for either one. Okay, I'm going to go with this one here. All right, so we're going to try to solve this proportion now to answer this word problem. So how do we solve this proportion, ladies? What am I going to do? I'm going to take 1260 miles and multiply it by what? 5 hours? And you know, I'm actually going to leave the units in this problem because I want to show you how the units work too. The units have to work out just as nicely as the numbers. So I'm going to take 1,260 miles and multiply by 5 hours. So 1,260 miles. I'm going to shorten miles up to MI times 5 hours. Shorten up hours to HR. And then I'm going to set the product of the means, 1260 times 5, equal to the product of the extremes. I'm going to take 3 hours and multiply it by X. So I'm going to have 3 hours times what? Times X. Anybody see how I cross multiplied and equated the cross products? Correct? All right. So later on, what is 1260 times 5? 1,260 times 5. Now you can just use your calculator to dial that up. And what is that going to give us?
300
Is that going to be 6,300?
or 6. Yes.
Okay. 6,300. And you know, the units are going to be miles times hours. Believe it or not. I know this seems strange, but it'd be miles times hours. And this is equal to 3 hours times what? X. What do I divide both sides of my equation by to get X by itself?
3.
By 3 hours, correct? So let's divide both sides of our equation by 3 hours. Got to divide the right side by 3 hours also. Now, 3 hours divided by 3 hours on the right side of the equation reduces down to 1. And so we're left with 1x or just X. What happens to the hour units on the left side? What happens to these hour units? What do you think happens to them?
They cancel out.
We can cancel them out. The hour units cancel out, leaving us with miles. And that's what X is going to be equal to, miles. Do you agree? See how the units work? Now, what's 6,300 divided by 3? You can get on your calculator and dial it up. 6,300 divided by 3.
2,100.
2,100. And so, ladies and gentlemen, we got our answer. And it has to be miles, agree? It has to be miles. All right. So what does this 2,100 miles represent? Can anybody in plain English explain to me what this 2,100 miles represents? What does it represent? 2,100 miles, 2,100 miles. What does that represent?
The X at the top.
Yeah, the X at the top. But what were we? I mean, what does that really pertain to in the context of this problem?
How far they'll fly in 5 hours?
How far the airplane will fly in 5 hours? Do you agree? In
Yes.
5 hours, that airplane's going to fly what? 2,100 miles, provided that it can fly in 3 hours, 1,260 miles. Because we're assuming the speed does not change. Do you agree the airplane does not speed up or slow down? It holds a constant speed for all times. Make sense?
Mhm.
All right, there's your answer, ladies and gentlemen. See how we attack that word problem there? We first of all read it, and then we set up a proportion using our given information in the word problem, and then we were able to solve for the missing quantity by just solving that proportion there. See that? See how that works there? Let's try another one. These might not be that bad. Let's see what else we got here. All right, I'm gonna look at one like number 6 here. It says if 10 ounces of a certain breakfast cereal contain 3 ounces of sugar, how many ounces of sugar does 25 ounces of the same cereal contain? Okay, so we're going to try to set up a proportion to formally answer this word problem here. So number 6 here. So Liz, I'm going to set up a proportion. It says if 10 ounces of cereal contain 3 ounces of sugar. So I'm going to say 10 ounces of cereal is to 3 ounces of what? Sugar. Then how many ounces of sugar will be in 25 ounces of the same cereal? Now, where would I on the right side put 25 ounces of cereal, in the numerator or the denominator, based on how I declared this rate on the left side?
You said cereal, so it'll be at the numerator spot.
Numerator has to be up here, because remember, the units have to be the same across numerators and denominators. So if we got ounces of cereal here, we would have to have our 25 ounces of cereal over in the numerator over here. Must have that. Therefore, our missing quantity is X. I'll call it X. You can call it any other variable if you want to, any other letter. I normally use X. X, therefore, will represent the amount of sugar in ounces that's in 25 ounces of cereal. And that's what they want us to know. That's what they want us to find in this word problem. How many ounces of sugar are in 25 ounces of cereal? So now that we got our, proportions set up here, we can actually, solve it. And to do that, we are going to cross multiply. So I'm going to take 10 ounces of cereal and multiply it by what? X. So, and I don't mind if you leave the units off until the very end, but at the end, make sure you attach the proper units as to what the number, represents. That's very important. So I'm going to say 10 times X. I'm just going to call it 10X. And then I'm going to set that cross product equal to 3 times 25. This is the proportion we have to solve, the equation we have to solve. So 10 times X is 10X. And what's 3 times 25? Well, you can, either do that manually or do that on your machine. And what's that going to give you here? 3 times 20, 75. Okay. And now we just have to solve a very simple equation for X by using our division skill we learned in section 5.3, correct? So what do I divide both sides by?
10.
By 10. Divide the left side of our equation by 10 and divide the right side of our equation by 10. On the left side, the 10 is reduced down to 1. 10 divided by itself is 1, and 1 times X is just better known as X. And now what's 75 divided by 10 on the right side of your equation? Well, you can do that, you can just take that to your calculator if you want. What would this give us as a decimal? 75 divided by 10. Looks like it's going to be 7 and what, 5/10, 7.5?
Yes.
And so now what was X again? Now it's very important at the end, ladies. I'm going to tell me what this pertains to. Very important to attach the appropriate units and or description here. What was X again?
Ounces of sugar.
Yeah, it's the number of ounces of sugar that's in 25 ounces of cereal. So please do indicate after the 7.5 that this is ounces of sugar. That's very important. I want to see that like on a quiz or a test, okay? Because I need to know that you understand what this number pertains to in the context of our problem. Very important. Otherwise, it's just a number, correct? We're not going to have a clue what it really pertains to. Yeah, it's 7.5 ounces of sugar. In how many ounces of cereal? In 25 ounces of cereal. And that would be a nice way if you could, summarize, your final answer, if you could indicate that what it pertains to like that. Done with that problem? Is making sense how we're solving word problems by doing proportional reasoning. We're actually using proportions to help us out here. I have a question. Is anybody in nursing or going into nursing in this class here? Anybody going into nursing in here? Nobody. Nobody's going into the medical field at all? Okay. Huh. Maybe day one, I should have asked us what we're going for. You know what I'm saying? Nobody's going into nursing? There's no future nurses in here, huh? All right, okay, no future nurses. All right, well, just for the record, ladies and gentlemen, they do use proportions to compute dosages in nursing. To do dosage calculations in nursing, they use proportions. Okay, I just thought I'd throw that out there.
Yeah, my mom uses that all the time, so she's
What's
a
that?
nurse.
Oh,
I
she
said,
is,
"Mom's
yeah.
a-"
Yeah. Proportions are used, to compute, dosages, maybe IV drip rates. Although maybe, the computer does that for them, you know what I'm saying, where they don't actually have to do the mental math. But it's still wise to question the output of a computer to, see if it's reasonable. Because listen, machines sometimes can make mistakes, and you could kill a patient if you administer a dosage that the machine says you should administer, when in fact it's not correct at all. You know what I mean? So you gotta be careful. And another thing in nursing is, like, if you have like a decimal amount of medication you have to administer, you should always have 0 that precedes the decimal point if there's no other non-zero digits to the left of it. Because, if you're like tired, you come in, you might read this without the 0 in front. You might read it as 25 milligrams. Okay, I have to administer 25 milligrams. Wait a minute, it's only supposed to be 25 hundredths of 1 milligram. Do you agree? That's a humongous difference in some cases, correct? So that 0 is like a flag, and it warns you that there's a decimal point here. Does that make sense there? Okay. So this 0 is kind of important in nursing circles. But yeah, proportions are used, ladies and gentlemen, for dosage calculations in nursing. Interesting. All right, let's move on down here. Number 8 looks interesting. It says a map is drawn so that every 2.5 inches on the map really corresponds to an actual distance of 100 miles. So ladies and gentlemen, if you drive 2.5 inches on the map, you've really driven what, 100 miles in reality. Agree? Do you agree all maps have a certain scale to them? Do we realize that all maps have a certain scale to them? Okay, let me show you really quickly what I'm talking about here. It's important to understand the scale of a map if you want to compute distances accurately. Suppose we have a map of Michigan. There's Michigan. And then we have a map of the United States here. Just pardon my quick shabby graphics here, but you kind of get the idea, correct? All right. Now, ladies and gentlemen, the scale of this Michigan map might be, they might say the scale is like 1 to 100. You see that there? 1 to 100. That might be the scale they use on the Michigan map, which might mean, you know what it might mean? It might mean like 1 inch is really equal to what, 100 miles in reality. So if you measure 1 inch on the Michigan map, that's 1 inch. That really represents what, 100 miles. Isn't that true there? Whereas on the United States map, the scale might be radically different. In fact, the scale might be, like 1 to 500 or something, which on the United States map, it might say, well, 1 inch is really equal to what, 500 miles. You see that there? So this might be 1 inch on this map, but it's really what, 500 miles in reality. Whereas on the Michigan map, 1 inch is only what, 100 miles. So different scales are used on different maps. And at least in the old days when we used to look at maps, scales were important. I'll be honest with you, I haven't looked at a map in a long time. I'm so bent on using my GPS system. You know what I'm saying? And I know all of us probably have used GPS on our phone or whatever, ladies and gentlemen. So maps are somewhat becoming obsolete in some sense because of the technology we enjoy today. But still, if you ever have to use a map, it's wise to know the scale. Do you agree? It's wise to know the scale. Otherwise, you're not going to know what distance is what in reality. He's trying to answer this question here. So on a map, every 2.5 inches represents 100 miles. If the actual distance between two cities is 350 miles, how far apart would they be on the map, ladies and gentlemen? Let's try to set up in a proportion to solve this problem. So I'm going to set up a proportion. I'm going to say 2.5 inches is to 100 miles. 2.5 inches is to 100 miles. As I don't know how many inches, I'll call it X, is to 350 miles. And there you go. Now we have a proportion right there, ladies. I'm going to take care of answering this word problem here. 2.5 inches measured on the map is to 100 miles in reality, as I don't know how many inches on the map is to 350 miles in reality. We got to solve for X. To do that's pretty simple, cross multiply. So we take 2.5 or 2 5/10, and we multiply it by what? 350? Then we're going to set that equal to the product of 100 times X, or 100X. Now we can solve for X. By the way, what is 2.5 times 350? Well, I don't know.
875.
Thank you. 875, and that's equal to 100X. And then we just what? How do we solve for X now? We go back to 5.3. What do we do? Divide both sides by
100.
100, and we got our answer. So take the 875 and divide it by 100. And of course, we will have divided the right side by 100 too. So we're going to get X is equal to 875 divided by 100. Now, I don't need a calculator to do this because I know when I divide a number by 100, that shifts the decimal point 2 places to the left. So 875 divided by 100 takes this decimal point 1, 2, and puts it between the 8 and the 7. Ladies and gentlemen, 8.75 what? What does that represent? In the context of this problem, what's the units attached to 8.75 or 875 hundredths? Would it be inches or miles?
Inches.
Inches. It's got to be inches. So on the map, these two cities are going to really be 8 3/4 inches apart, right? But in reality, that represents they're 350 miles apart. Okay. Let's see how we solve that map problem using a proportion there. So this is like the scale of that map, 2.5. So on that map at the bottom, they might have in fine print 2.5 and have the colon and then put 100. You know what I'm saying? They might show the scale at the bottom of the map like this. Have you ever seen scales like this on a map with the colon symbol? That's the scale of your map. You ever seen that before on a map? Maybe at the very bottom somewhere, written small. That's the scale of your map. That tells you how to read your map as far as the scale that's being used. All maps have different scales. Okay. All right. So these are kind of like interesting problems here. I'll come back maybe and grab that one there. Tell you what, let's do this one right now, Liz. We'll call this classwork number 2. Problem number 10. Classwork number 2. We'll be adding the classwork 2, so just hang on to that. But try to do number 10 for classwork 2 right now. when you get done with number 10, I want you also to do number 14. Number 14. All right, number 10. Of every 17 parts manufactured by a certain machine, we assume that one will be defective, meaning one part's going to be bad. How many parts were manufactured by this same machine if 8 defective parts were found? Anybody get that result? How many parts were manufactured?
136.
All right, you got 136. 136 parts were manufactured.
Yeah.
Oh, sorry.
Anybody get anything different than that, or same thing as that, or
I got the same thing.
136?
Yes.
Okay. And so that sounds good. 100 and what was it again? 136?
Yes.
Nice job. 136. And you are correct. And does anybody need to see that one? How that one was done? 136 parts were manufactured. That is correct. Well, I'll show it to you anyways, right there quickly. Set up a proportion, 17 parts is the 1 defect, as X is to 8 defects. 17 times 8 gives you 136, and that's equal to 1 times X. That is correct. All right, how about the next one here, which is number 14. It says a family plans to drive their car during their annual vacation. The car can go 350 miles on a tank of gas, which is 18 gallons. The vacation they have planned will cover 1,785 miles. How many gallons of gas will they need? Anybody get that?
91.8 gallons of
Okay,
gas.
91.8 gallons of gas. Anybody
Yeah.
else get that? All right, 91.8 gallons of gas, correct? They're going to be needed, assuming the vehicle continues to burn gas at the same rate. Do you agree? That's the key assumption, that it continues to burn gas at the same rate. If that's not true, then this is not accurate at all. Okay. All right, so using proportions to solve word problems. Does that seem like something you might be able to do if I put maybe a couple of these problems like on a future quiz or test, ladies and gentlemen?
Yeah.
Okay. All right, we just have one more section to do now. That's section 5.6. I want to run off to the textbook immediately for 5.6. It's involving similar geometric figures, ladies and gentlemen. Similar figures is what it's entitled, 5.6. Similar shapes in geometry. And what are similar shapes or similar figures in geometry? Like if two triangles are similar, what does it mean? Or if two rectangles are similar, what does it mean to say they're similar? Well, similar shapes have the same shape, but different sizes, different size. So, ladies and gentlemen, similar figures are figures that have the same shape, but they have different size. This is a well-known fact for similar shapes. It's a well-known fact for similar shapes that, number one, corresponding sides are in proportion with one another. Corresponding sides of similar figures or similar shapes are in proportion. And there's that word proportion again. Another interesting fact about similar shapes or similar figures is that corresponding angles are equal in measure. Or sometimes we use the word congruent. You ever see that word before, congruent? Anybody ever take geometry before or touch base with it a little bit?
Yeah.
Congruent. Okay. That's two very important consequences of similarity, ladies and gentlemen. Corresponding sides are in proportion with one another, and corresponding angles are equivalent in measure to each other. Very important. And you know, this concept of similarity is used all the time in engineering to design, you know, maybe like airplanes or boats or cars. Okay, similarity is used all the time where they build model size, scale models to represent the life size thing they're actually going to build. They use little scale models. Okay, and because the scale model is similar to the real thing they're going to build, they can use the concept of similarity, and they can basically use these properties, which are true for similar shapes and similar figures, to analyze what happens, what's going to happen to the real life size thing based on what happens to the model, okay, that they develop. All right, so similarity is very important. I want to show you this this figure right here. Suppose, ladies and gentlemen, these two triangles here are similar triangles. What does it mean to say these triangles are similar? Well, Does it look like these triangles have the same shape?
Yes.
Yes, they do. But they're not the same what?
Size.
Size, but they're the same shape. So if these triangles are similar to each other, what must be true is that corresponding sides of these triangles must be in proportion with one another. So later on, we would say that side A corresponds with what? What side does side A look like it corresponds with?
D.
Side D, yeah. And side B looks like it corresponds to side
E.
E. And side C looks like it corresponds to side
F.
F. Do you agree if you were to take this smaller triangle to the right and if you were to blow up the length of each of these sides, proportionally speaking, we could make this small triangle literally become the big triangle?
Yeah.
Literally. You agree? Yeah, we could do that. In fact, ladies and gentlemen, it's a well-known fact then that the corresponding side ratios are in proportion with one another. So I could say side A is to side D as side B is to side E as side C is to side F. Everybody see the proportions we can establish between corresponding sides? Pretty interesting, huh? And so similar shapes, enjoy the property of this concept of proportionality between corresponding sides. And that brings us to our problems that we can immerse ourselves in now involving similar shapes. And these problems begin on page, wait a minute, what page do they begin on? Page 256, on page 256 in our book. All right, this is to begin here. All right, listen, we'll do number one here. Notice it looks like, well, they're telling us that both these triangles are similar to each other. In other words, they have exactly the same shape, but they're not the same size. But nonetheless, we should still be able to solve for this missing side H here. Do you agree? By setting up a valid proportion involving corresponding sides. So what proportion could I set up, ladies and gentlemen, in order to solve for this missing side H between these two similar triangles? Can somebody give me a valid proportion that I could set up? Anybody, give me a valid proportion. We could say maybe, I'll give you an example. We could say maybe that the first one or one of them that's valid, there's others. We could say side that has a length of 6 is to what side of the smaller triangle?
4.
4 as back to the big triangle. The side has that side that has a length of H is to the side what for the small triangle?
6.
6. Do you agree that we could set up this proportion involving corresponding sides between the big and the small triangle? We can do that because they're similar triangles. So we can set up this proportion. There's other proportions you could have set up though. That's not the only one. For instance, let's go back to our figures. I could have done this. I could have said size 6 of the big triangle is to side H of the big triangle. So I could have said 6 is to H. I could have said 6 is to H as side 4 is to what? 6. Do you agree? 4 is to 6. That would also be a valid proportion that would enable us to solve for H. So both these proportions are equivalent to each other. They would give you the same value for H. They're equivalent proportions. So it doesn't matter which one you set up, this one or this one. Okay. Let's see here. Is there anything else? All right. Now, ladies and gentlemen, I'm going to give you a proportion that is not valid. And I want everybody to understand or try to figure out why it's not a valid proportion. In other words, could I got to be careful here. Okay, could I say this? 6 is to H, 6 of the big triangle is to H of the big triangle, as side 6 of the small triangle is to side 4. Is that a valid proportion? Is this valid, ladies and gentlemen?
No.
Let me try to hurry up and just sketch this and show you why it's not valid. Okay, look at, this is not a valid proportion because look at, I took the big side of the, I took the side of the big triangle, which is 6, and I said it is to H. I took this side is to this side, but then I crossed things up. I said that's equal to this side to this side. Wait a minute. That's not right, ladies and gentlemen, is it? It's not right because look at side 6 here does not correspond with side 6 over here. Do you agree that this side 6 does not correspond with the side? And H does not correspond with side 4, does it? This is invalid. That's an example of an invalid proportion. That would not work. This one's valid because side 6 of the big triangle corresponds to side what? Corresponds to side 4. Do you agree? Of the small triangle? And side H of the big triangle corresponds to side 6 of the what? Small triangle. This is a valid proportion. Or this would be valid. Side 6 of the big triangle is to side H of the big triangle, as side 4 of the small triangle is to side 6 of the small triangle. Why is this valid? Because side 6 corresponds with side 4, 6 corresponds with 4, and H corresponds with what? 6. That's why this is valid. So do we understand what's valid and what's not valid? So be careful, okay? All right, let's solve this one here. It doesn't matter which of these two you solve. They give you the same answer. Let's solve for H here. So what do? I got 6 times 6 is what?
36.
And we set that equal to 4 times H. So we got 36 is equal to 4H. Divide both sides by what? 4. And what does H have to be? You agree H has to be 9?
Mm-hmm.
There you go. We solve for the missing side of the big triangle using the proportion for corresponding sides. All right, so we just solved for that missing side of that large triangle, which is similar to the small triangle. All right, ladies and gentlemen, I want you to do number 2. We'll call this classwork 3. We'll start building some problems that we'll throw into what will be called classwork 3. You try number 2 now. Solve for the missing side of that triangle. Number Okay, what does side H have to be equal to? Anybody?
12.
Mm-hmm.
Well, yeah.
All right. And you know, your proportion might be a little bit different than mine, but we both get the same answer, correct? And I think there's a couple of different choices for your proportion, but I went with this. Mhm.
I got the same answer. I just had
Good.
mine differently.
Good, good. It don't matter because there are some other equivalent proportions to mine that would give you the same answer, and they're just as valid as mine. Okay. All right, we good on that so far? You know, this is not just true with triangles. This is also true with like other geometric shapes. Corresponding sides are in proportion with one another. For instance, see if you can do problem number 8 here as part of classwork 3. Solve for the missing side X for this rectangle, this large rectangle that's standing up on the left. See if you can set up a proportion to solve for X. So we're doing problem number 8, classwork 3. Okay, anybody get the link for size X?
Yes, it'll be 15.
15. That is correct. And your proportion might be a little bit different than somebody else's proportion because there's different choices here. But the bottom line is we better all get 15 for length X. And everybody good on that one? We all got 15 for number 8 for X? Okay, look at this concept of proportionality. Whoops, oh, hold on a second here. Look at these down here, ladies. I mean, these are interesting. I want to not really so much the triangle, but I want to go down to one like this. Let's look at number 15 here. Let's look at this. Looks like a rectangle. Do you agree? A, B, C, D. Do we see this little rectangle here? Now, what is the length of this side of the rectangle? Well, just count the number of little, little tick marks here or squares. You got 1, 2, 3, what, 4? From D to C, it's 4. Okay, so the length is 4. And what happened to the length when they blew it up to the picture to the right? from DC to HG, which are corresponding sides of a rectangle we're trying to draw to the right, what is the distance now between H and G? 1, 2, 3, 4, 5, 6, 7, what, 8?
Mhm.
So what happened to the length of DC to go to HG? We went from 4 to 8. Do you agree? What did we multiply the length of DC by to get the new corresponding length of HG?
Times 2.
Times 2. So ladies and gentlemen, if I want to draw a rectangle, okay, over here to the right, that is larger than the rectangle ABCD over to the left, but still it must be similar to ABCD. What am I going to have to multiply all side lengths by of ABCD to duplicate this new rectangle to the right? What do you think? What are we going to have to do with all side lengths of ABCD so that we can generate a similar rectangle to the right?
You have to multiply.
We're going to have to multiply all side lengths by
Wouldn't it be 2?
2, exactly. Since the length got doubled, the width has to be doubled. So the distance between C and B, which is what, 1, 2, 3, would now become what distance over here? 3 times 2 is, it would have to become 6. 1, 2, 3, 4, 5, 6. Do you agree you put a point right here and drop a line down here and you would have the new width, wouldn't you? Then you could draw the bigger but similar rectangle to ABCD. Does that make sense how we could, draw similar figures using these little figures superimposed on these little graphs here? Okay. All right, that might be an interesting exercise. Maybe I'll assign a couple of these out of here. Now it's going to be a little bit, well, maybe a little bit more difficult with triangles, but with this number 11 here, all you have to do, ladies and gentlemen, is just extend the sides of AC and AB, and then don't worry about this diagonal side because you'll just connect the endpoints. For instance, AC has what length right now? 1, 2, 3. 3 units long, AC. And then it went to what length? DF. What is this length? 1, 2, 3, 4, 5, what, 6? So they doubled the length of AC to get DF. So you would have to double the length of AB. Do you agree? And AB is what length? 1, 2, 3, 4. So now AB would go from being a length of 4 to a length of what? 8. Do you agree? 1, 2, 3, 4, 5, 6, 7, 8. Right up here. We would draw the side up to here. And then we would connect this point right here, ladies and gentlemen, with a ruler. We would connect this point down here with a diagonal to what? Point F. Do you agree? And we would have our bigger but similar triangle. Does that make sense? That you think you might be able to do a couple of these problems for homework if I assign them? All right. All right, let's go down and see what else awaits us down here. Okay, we already did one like that. Oh, here's an interesting one. Number 25, it says a tree casts a shadow that's 38 feet long while the 6-foot man casts a shadow that's 4 feet long. How tall is the tree? Now, the picture they've drawn for you, ladies and gentlemen, just does not do justice at all in helping you to solve this problem. So I'm going to draw a picture for 25 that will be much more understandable as to what we need to do. So just bear with me here as I sketch a picture here. Okay, hold the show here. And then I'm going to draw a little picture of a person here. Okay. Well, hold on a second here. I'm going to draw the picture of a person over here. Okay, so hold on. I'm almost done here. Okay, and then we got the sun up in the sky here. Okay. Now, it says the shadow cast by the tree is how long?
35 feet long.
35 feet long. Okay. So, and let's see, while a 6-foot man casts a shadow that's 4 feet long. Okay. Now look at this. Let's try to draw a picture here. Here's my tree here. I know it's a crappy tree. And here's a person over here, a 6-foot tall person. That casts a shadow. Now the tree casts a shadow of, what was it, 35 feet in length? So the ray of the sun, ladies and gentlemen, is going to come down and strike the tree here. And then it's gonna what? It's gonna cast a shadow on the ground, correct? And the length of this shadow down here, they told us was what, 35 feet?
Mm-hmm.
That's for the tree. You, can you see a triangle here? Can we see like a right triangle here, ladies and gentlemen?
Mm-hmm.
With the tree and its shadow on the ground? Well, a ray of sun is also, a ray is gonna also come off the same sun, hit the top of the head of the person over here, and they're gonna cast a shadow on the ground too. But what's the length of this shadow for the person?
6 foot.
No, I think the length
No,
of the shadow was only 4 feet, right? But the person was how tall?
Oh, he was
I think the person was 6 feet tall,
6
correct?
foot. Yes. Oh, yes.
Hey, do you see two right triangles in this picture, ladies and gentlemen?
Mm-hmm.
Big one, small one. And I'm gonna pull those triangles out of the picture so we can better see what's going on. So here's the big right triangle here. This is the tree and its shadow. Okay, so like that. So the length of the shadow of the tree is 35 feet. We don't know the height of the tree. We'll call it X. And we got this small triangle created by the person. The person is 6 feet tall and they cast a 4 foot long shadow. Wait a minute here. They cast a 4 foot long shadow. You see that there? So this is a 4 foot long shadow and the person's 6 feet in height. Ladies and gentlemen, do you think we have enough information to solve for the height of the tree?
Mm-hmm.
We can find how tall that tree is, can't we? Because that's what I'm calling X here. Here to here is X, okay? All right, let's set up a proportion. We could say like X is to 6 feet. So X is to 6 as 35 is to what, 4? That would be a valid proportion. Now we want to solve for X. Cross multiply, so X times 4 is 4X. Set that equal to 6 times 35. So we have 4X is equal to what, 6 times 35?
210.
10. Divide both sides by what, 4 now, right? And we'll solve for X here. So the height of the tree is going to be 210 divided by 4, which is going to be 52.5. Is that correct?
Yes.
How tall is that tree, ladies and gentlemen? 52.5 feet tall. Do you agree?
Yes.
And you know, the beauty of this, we did not even have to climb the tree to measure its height. We just did proportional reasoning by staying safe on the ground. Do you agree? By using lengths of shadows. Isn't that neat? Proportional reasoning. That tree's 52.5 feet tall. Isn't that cool how we did that problem there? All right. One last problem, ladies and gentlemen, for classwork 3, and this is going to wrap up the session today. I just want you to do problem number 26. Okay. Number 26, see if you can draw a picture to answer that question. This is the last problem for classwork 3, number 26. Anybody crank out the height of the building? You know, 32 divides on itself once, goes in 128 4 times. And what's 4 times 24? Did anybody get 96 feet for the height of the building?
I did.
Nice job. That's the height of the building, ladies and gentlemen. It's 96 feet tall. And I'll tell you, I'd rather stay on the ground and do the math rather than try to climb that building and measure the height. I'm afraid of heights. I wouldn't be climbing no 96 feet up. That's a small building too, isn't it? I mean, that's not very tall at all. I mean, we got buildings at what? Gosh, hundreds of feet tall. I think there's a building over in Dubai that's the tallest building on the planet. I forget how tall that thing is. I think it's like 1,000 some feet tall or something. It's way up there. But there you go, ladies and gentlemen. What do you think? Proportional reasoning is what we tackled today at 5.4, 5.5, and 5.6. All righty. So that's it. You think just make sure you get me your classwork 1, 2, and 3 by midnight tonight. Just send it to me. You can take pictures of it or scan it. Just get it to me. And I'll make available the next quiz. I will make that available probably by the end of today, by midnight tonight. I'll try to make that available. And I'll probably make that due by midnight Monday night. Okay? All right, now when's the first quiz due? It's due by midnight on
Friday.
Friday, yes. All right, ladies and gentlemen, and I will also update your homework assignment on Canvas. Are we staying up with the homework? Okay.
Yeah, I had a question.
Yeah.
I know I asked the other day, you said the 3rd. Is it the 3rd or the 10th that all of us do?
Well, let's see. It's called homework set number 1, isn't it? Because
Yeah.
we only have 2 homework sets in this class. So let me dig this up here. The homework set number 1 is due on February 3rd by midnight. Okay.
Okay.
So the textbook homework we're doing up right now will be due on by midnight, February 3rd. And I'll indicate with an email exactly what I want you to send in from that first set of homework as proof of having done the whole set. Okay. Because I don't want you to send me the whole set. You'd have to scan way too many pictures already.
For sure.
So I'll tell you exactly.
Are we gonna know? We're gonna know that in time in advance to be able.
Oh yeah, I'll give you that email. Sure. When the time
Okay.
draws near, I'll let you know precisely what it is I want you to turn in. Okay.
All right now.
All right. The key, ladies and gentlemen, is to try to stay up with the homework because, well, for obvious reasons, you never want to get behind in a math class. That just makes things miserable. But you want to stay up with the homework because it helps you to keep the gears moving in the mind and keeps the material coherent in your thinking. And you'll do a better job on quizzes and tests by doing that, correct? Yeah, don't wait till February 2nd and say, okay, it's time to cram in all the homework. Oh my gosh, you know what I mean? Don't do that to yourself. Okay. All right. Any other questions or concerns? If not, ladies and gentlemen, you have a great weekend. Have a safe weekend. Hopefully I'll see you on the other side of this life on Monday. Okay.
All right.
All right. All right. Take care.
Thank you, you too.